All right, good morning, everyone. Hope everyone's doing great and everyone is all right. We get into 8.1 today, measures of central tendency. We may do 8.2, we'll see. So 8.1, the first thing in 8.1 is the mean, or in other words, the average. In statistics, your average is called the mean. And so you calculate it like you would calculate the average. You take all the data values that you have, add them together, and then divide by the number of data values that you have. Yeah, trying to get this out of here. So, quick example, we have our data set is 1, 2, 3, 4, 5. Say you add those numbers, and then we divide by 5 because we have 5 numbers. That'll be 15 over 5, which is 3. So our average or our mean is 3. Somebody asked about the final exam. Final exam is online, and the dates will be the last week of school. You're gonna have 3 or 4 dates to choose from. One that's specific to this class, but I'll let you take it in any one of my other classes. I don't mind. But I'll send that out here like 2 or 3 weeks before that final week of final exam testing. Now that final exam scheduling is already posted somewhere on the website, on NSU's website. You guys should have access to it. But yeah, I don't have that specific date right now. I just know it's that last week, and it's called final exam week for North State. All right, everybody okay with the meeting? Next one's median. Think about the middle when it comes to median. That's your middle value. So that first step, always make sure you hold true to the first step. A lot of times people do forget that first step. When you list all your data values from least to greatest. From there, depending on the scenario that you have, you're going to go to this next step. It says, if the number of data values is odd, you're going to take the middle value. If the number of data values is even, you'll take the mean of the two middle values. So I'll show you that in a second. All right, scrolling up some. Anybody on 2A? All right. So we got a data set for both scenarios. So as the first set, we have 1, 2, 3, 4, 5. We have an odd number of data values. So if you have an odd number of data values, then you have a legit middle number. In that case, in this case, it would be 3. For the second data set, I have an even number of data values. I have 1 through 6. So we take the 3 and the 4, which are my two middle values, add them together and divide by 2, and that'll give me 3.5, which is right there in the middle of the data set, just like the 3 was of the first data set. So next one. Another one in red. About purple. Okay. So mode, that's the data value that appears the most. So the data value, I mean, it is possible to not have a mode. It is possible to have more than one mode. Bimodal means you have two modes. Multimodal is having more than two. So we have this data set of 178, 235, 769, 147, 456, 789. The mode would be 7 because it appears the most. That's good. Bless you. Next one's mid-range. That's your lowest data value plus your highest data value divided by two. So my data set is 1 through 5. If I want to find the mid-range, I take the 1 and the 5, lowest and highest value, add them together, divide by two. That give me 3. Next one, I think is the last one out of this section, the weighted mean. So you're going to take the sum of each data value times its weight and divide it by the sum of all weights. So sum means addition. That's what that little circle word is, ADD, addition. And then, of course, there's multiplication. All right, so we have Randall has 38 credits with a grade of A, 22 credits with a grade of B, 7 credits with a grade of C. What is the grade point average? Based on the fact that the GPA has value as 4 points for A, 3 points for B, and then 2 points for C. Hmm. Mhm. So once again, 30 credits, 38 credits as an A, 22 credits with the B, and then 7 credits with the C. So you see how to break down. We know that 4 points go to an A, 3 points go to a B, and then 2 points go to a C. So those 38 credits are being multiplied by 4, 22 credits being multiplied by 3, and then 7 credits being multiplied by 2. And then on bottom, we have all of the credits added. So multiplying those out, you get 152 plus 66 plus 14 over that 67. Finish doing the math. Ultimately, you'll get 3.46. All right. So that's it for 8-1. Questions before we look at 8-2. 8-2 is relatively short as well. Good. Still see writing. So wait a second. All right, we good. All right, so let's look at 8.2, measures of dispersion. So dispersion is just the degree to which the data is spread out. All right. First thing here is the range. So you have your largest data value minus the smallest data value. So if our data set 1 through 5, once again, we'll take 5 minus 1, which would be 4. Holding on to black statement. All right, anybody holding on to range? All right, standard deviation measures how far a data value is from the mean. Don't forget the mean is your average. And then your variance is the standard deviation squared. It's just another way to measure the spread of your data. All right, anybody holding on to the black? All right. So let's look at some notations for symbols. So when it comes to statistics, you have your population and then you have your sample. Your population is the larger body. Your sample is what is exactly what it sounds like, just a piece or the sample of that larger body. So an example of that is the student population here at Norfolk State would be all the students. And then this class would be a sample of the student body. That would be the population of students that we have here. So certain symbols and statistics will let you know whether you're dealing with a population versus dealing with a sample. And it does matter because when you're dealing with statistics, sometimes the formula for the population will be slightly different than the formula for the sample. So you would get a different number. So X is always going to be our data value. I'm going to put this right here. Let's see. So no matter whether you're dealing with a sample or the population, X is always your data value. And then Greek letter mu, it kind of looked like a U with an extended stem to the left. Greek letter mu is your population mean, population average. The letter O with the stem extended to the right is your population standard deviation. That's Greek letter sigma. That's actually lowercase sigma. I know most of you seen capital sigma, and that's the symbol right here. That actually represents the summation or the adding up of all values. But lowercase sigma is your population standard deviation. And then sigma squared is your population variance. Capital N is your population size, population size. All right, so those are your population symbols. Well, hold on to that word notation. All right, then our sample symbols, X bar. So any letter with that bar over top of it, you would just be that letter bar. So like I wrote right here, if you have Y with the bar over it, that's just Y bar. So X bar represents your sample mean. Lowercase s represents your sample standard deviation. Lowercase s squared is your sample variance. And then lowercase n is your sample size. Scroll up. All right, so as far as you guys don't have Stat Crunch. As far as calculating standard deviation and variance, you need to find an app calculator website or something along those lines that is going to be reliable for you to be able to calculate it. And you test the reliability as you go throughout your homework. If you put in a homework problem and it doesn't work, then you can't use it. So you're going to have to test it. You need to test it before test time, before you get into that final exam, for sure. So you would be testing whatever it is that you decide to use throughout your homework. So remember, you have 100 attempts to get your homework correct. So you hopefully with the 100 attempts, you would have been able to find something reliable that you can use on your test and on your final exam. But it needs to be able to calculate variance and standard deviation. You don't want to have to do it by hand. Now you can, and I can show it to you. I wouldn't take up class time. If you really want to do it by hand, come to the office hours and I'll show you because I'm not going to hold everybody else, responsible for that. One website, easycalculation.com. Come to find out lately, it only works with certain, conditions. So I'll show you another one in a second, just giving everybody a chance to write. And most definitely, you don't have to use the one I show you today. I'm just giving you an example of something you can do to find standard deviation and variance. Anybody holding on to green? Mhm. Oh, once again, when it comes to the final exam, I don't have that exact date. I just know it's the final week of classes. Our class ends, I believe December 6th is the last day of class. So it's either that week or the week after. But NSU has made that schedule available to you if you go online and look it up. I haven't looked it up yet for the exact date. So, all right, but it will be online. So. All right, so let's look at where it go. Yeah, go here. So I will Google standard deviation. Let's see, I got it. Deviation calculator. Calculator soup is one that's pretty straightforward. And notice it says sample or population. Make sure you're paying attention because they tell you specifically which one they want from you. And so those numbers I gave, we have 2, 4, 7, 12, and 15. And so if you want the sample, all you would do is hit calculate. And notice how I give it to you right here. And that's what I have on the notes. 29.5 for the variance, 5.4 for the standard deviation. And those are using the symbols of S and X bar. Then if you want population, just change the population to calculate. And then notice the symbols that they're using, sigma and mu. And it's just that simple. So basically, like I said before, make sure you have something reliable that you can depend on in order to be able to calculate standard deviation and variance. All right, questions on that? All right, so that's it. That's 8.1 and 8.2. Next class, we'll get into 8.3, and then we'll talk about how we're going to move forward. All right, you guys have a good one. Be safe. Have a great weekend, and I'll talk to you next week.